Hello and welcome to Physics Problems One by One. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. Today's problem is again about the body that is thrown on the angle, and this is x, and this is y, and this is v0. And what happens with the body we already know, it flies. And this is a parabola, right? And at a certain height, certain point on this trajectory, it has a speed v, and this speed v is directed, of course, on the smaller angle, because the curvature of the trajectory and the speed is always directed as a tangent line to the trajectory. So, and they ask us to find v when the h is known. So h is known and the v is a question mark. And of course the straightforward solution, which is not good, tell you right away, that's not the best solution, but what we did so far many times was that v, at that point, the projection of v is the same like at any other moment of the travel. Projection of velocity in this direction is the same, it does not change, it's a move with a constant speed in this direction. But along the y-axis, so this is vx, and vy at that point, it is equal v0 sine alpha minus gt. All right, so we know at that moment, we know v, we know vx, and we know vy. So we have this triangle, and from this triangle we have Pythagoras theorem. And it's always with vectors, it's always like that. And so they want us to find v. So obviously we have this system, and we want to substitute vx and vy here. So let's do it. And we have v squared equal v0 squared cosine squared alpha, because I simply put this here and I have to square it, right? Plus, and I have to put here v0 sine alpha minus gt, and I have to put it in the square. So I have v squared equal v0 squared cosine squared plus, and this is a minus b. A minus b squared should be, if it's not, go to my algebra playlist and check what it is, how it is. But it is a squared, which is v0 sine squared, and by the way we already see that v0 squared will be factored out, and it will be cosine squared plus sine squared, which is 1. But I run a little bit ahead of myself, so say a squared minus 2ab v0 sine alpha multiplied by gt, because this is a and this is b. So gt and then plus gt squared, g squared, t squared. And I have this, and as I promised to you, v squared equal v0 squared, and here would be cosine squared plus sine squared, because I factor out v0 squared between those two. So if I go opposite direction and open brackets, open parentheses, there would be this multiplied by this plus this multiplied by this, which is exactly like this, so it's the same. And this part I write as this: 2v0 sine alpha gt plus g squared t squared. And everything is good, but I don't have h here at all. And h is given, and I have to use this h somehow. So what comes to mind is the movement along this axis. So I start with this speed along y, and when I start, this is acceleration g, and this is acceleration is negative, so I can say h equal v0 sine alpha t minus gt squared over 2, right? And one other thing I can do here, I have g and g, so I can actually, let's finish this. V squared equal v0 squared, right? And this is 1. I don't know why I ran away right away. I have to finish this. And g I can factor out. G, and I can have, already looking here, let's factor 2g. So if I factor 2g, I will have from here v0 sine alpha t, and here, and I have minus, so minus would be here, gt squared over 2. So what I did here, I factored 2g and minus, so here I multiply this, it will be minus 2g v0 sine alpha t, which is exactly this. And then minus by minus would be plus, 2 would be gone from the bottom, it's 2, I don't have space. And g would go to the upper part of my fraction, nominator, and it would be g squared. Right, so now I have h equal v0 sine alpha t minus z. So if I look carefully, I can see that this is exactly h. It's just a miracle, but it is. So I have v squared equal v0 squared minus 2gh. And of course I can say that v equals square root of v0 squared minus 2gh. And it would be my solution. But when we have such, and it's perfect solution, although I don't like it. And I don't like it because it's too long. And later, when we will be looking on the law of conservation of energy, we can see that this, I will not wipe it out, I just will say this is a law of conservation of energy. Because at that point, we have kinetic energy mv squared over 2 plus potential energy, body mass m, height h, this is an energy, equals initial energy at that point, mv squared over 2. And if you cancel m because it's a common factor, you factor it out, you received exactly this, and 2 is this, so I don't want to go into those details, but basically this and this are totally identical from mathematical point of view. So it's possible to say that we prove the law of conservation of energy. I wouldn't go that far with a statement, but I will say that this is an indication, this simple formula that we receive, that V has no relation with alpha, only the height. It tells us something, that something big is going on here, and yes, this big is the law of conservation of energy. And everything matches up, and I feel good about this. I hope you feel good about this too, so you will like, and you will like to see new problems, so you subscribe and bell and question and problem. Thank you.